Hello and welcome to the Arduino with C++ course. As part of the Learn Robotics program, this course will help you to develop the basic programming skills using Arduino C++. Let's review the course unit details. This course provides a comprehensive introduction to Arduino C++ coding with Arduino IDE. Arduino serves as the central control unit for robots, directing various components through Arduino programming language. The course aims to familiarize you with the Arduino platform and the field of physical computing. You will gain a solid foundation in programming fundamentals and C++ syntax, while learning how to utilize Arduino for sensor control, actuation, and device communication. Throughout the course, you will gain practical experience using Arduino IDE. You will learn how to connect different sensors and actuators to an Arduino board and employ C++ code to regulate their behavior effectively. Additionally, the course emphasizes best coding practices, covering techniques for organizing and formatting your code to enhance readability and maintainability. By the course's conclusion, you'll possess the necessary skills and knowledge to embark on your own Arduino projects and delve into the vast potential of physical computing. The course is designed with the following aims in mind: introduce the Arduino platform and its capabilities. Develop basic programming skills using C++ within the Arduino IDE. Equip students with the knowledge to interact with electronic components using Arduino. Provide a foundation for building interactive and functional electronic projects. By the end of this course unit, you will be able to describe the Arduino platform and its role in electronics prototyping, navigate and utilize the Arduino Integrated Development Environment IDE, write basic C++ code for interacting with electronic components. Explain the role of tokens, variables, and data types in C++ programming. Utilize operators for calculations and manipulate data within your code. Implement control flow techniques like conditional statements and loops. Define and utilize functions to structure and reuse code efficiently. Control the digital and analog outputs of the Arduino board. Read data from digital and analog sensors connected to the Arduino. Employ debugging strategies to identify and fix errors in your code. Apply your knowledge to build practical projects like an automatic street light system, a burglar alarm system, and an obstacle-avoiding robotic car. The syllabus covers an introduction to Arduino, Arduino IDE, and C++, focusing on programming basics like variables, loops, functions, and conditional statements. It includes working with analog/digital inputs/outputs, debugging, and troubleshooting strategies. Projects involve building an automatic street light, a burglar alarm system, and an obstacle-avoiding robotic car. This course is designed for students with prior experience in block programming and basic electronics. It focuses on using the C++ to program microcontrollers for robotics applications. Introduction to Arduino. Arduino is an open-source hardware and software company, project, and user community that designs, manufactures, and supports single-board microcontrollers/microcontroller kits and software for building electronic devices such as Arduino boards. Arduino boards. Arduino boards are a series of microcontrollers designed for prototyping which are equipped with sets of digital and analog input-output I/O pins that may be interfaced to various expansion boards, shields, or breadboards for prototyping and other circuits. The boards feature serial communications interfaces, including Universal Serial Bus, USB, on some models, which are also used for loading programs. Arduino Language IDE. The microcontrollers can be programmed using the C and C++ programming languages, using a standard API, which is also known as the Arduino Language IDE. Arduino offers a variety of boards with different numbers of input, output, I/O, channels, form factors, and processors to cater to various project requirements. The Uno and Pro Mini use the 8MEGA328P microcontroller, while the Zero uses the ITSAMD 21G18 ARM Cortex M0 Plus, and the Leonardo uses the 8MEGA32U4. The Mega and Do are the largest boards, while the MKR1010 and Lilipad are designed for specific applications like IoT and wearables. Arduino Uno R3 is a microcontroller board based on 8MEGA328, a single-chip microcontroller created by Atmel, designed for prototyping. It has 14 digital input-output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSB header, and a reset button. It contains everything needed to support the microcontroller. You may connect it to a computer with a USB cable or power it with an AC to DC adapter or battery. The diagram shows the functions and the arrangement of the pins on the board. You can view the Arduino Uno schematic here. Arduino Uno parts. ATmega microcontroller. The brain of your Arduino Uno. USB port. Used for powering your Arduino Uno, uploading your sketches, programs, to your Arduino, and for communicating with your Arduino sketch. Power connector. This is how you power your Arduino when it's not plugged into a USB port for power. It can accept voltages between 7-12 V. Power LED indicates that your Arduino is receiving power. This light is useful for debugging. Reset button resets the ATmega microcontroller. On a physical board, you might have to use it if your board isn't acting the way you expect. G&E and 5-volt pins. Use these pins to provide plus 5-volt power and 0V ground to your circuits. Digital pins interpret binary data, on or off, from an input component like a switch. Digital pins are used with digital read, digital write, and analog write. Analog write works only on the pins with the PWM, pulse width modulation, symbol. Analog pins interpret a range of signals from an input component. Use these pins with analog read. Pin 13 LED, the only output built into your Arduino Uno. This LED is very useful for debugging. TX and RX LEDs. These LEDs indicate communication between your Arduino and your computer. Expect them to flicker rapidly during sketch upload and while the board communicates with the computer. These lights are useful for debugging. You can view the Arduino Uno kit here. Sensors. Sensors can be both binary or a range. Usually, sensors that measure a range of values vary their resistance to reflect their detection. Arduinos can only sense voltages, not resistances. Sensors that only vary their resistances require a circuit called a voltage divider to provide the Arduino a voltage. Here you can view common sensors used in various applications. For example, sensors for detecting light, angle, motion, force, temperature, and switch states. It also includes potentiometers for dials, accelerometers, and infrared sensors. Shields are circuit boards that plug into the top of an Arduino. They extend the capabilities of an Arduino, e.g., motor, Ethernet, GPS, and prototype, etc. Working with Arduino IDE. An integrated development environment, IDE, is an application for software development that provides comprehensive tools into a single graphical user interface, GUI. An IDE normally consists of a source code editor, build automation utilities, and a debugger. Some IDEs contain the necessary compiler, interpreter, or both. Arduino IDE is a fully featured development environment that is written in the Java programming language and provides simple one-click mechanisms to compile and upload programs to an Arduino board. The Arduino IDE is based upon the Processing IDE and the Wiring IDE, which builds on top of it. When we work with ESP32, we can use the Arduino IDE Integrated Development Environment, a software available for all the major desktop platforms, macOS, Linux, Windows, which gives us two things: a programming editor with integrated library support, and a way to easily compile and load our Arduino programs to a board connected to the computer. A program written in the Arduino programming language is called Sketch. A sketch is normally saved with the .eno extension. The Arduino IDE interface is divided into several key areas. The top bar holds menus for controlling the program, while the toolbar provides quick access to common functions. The main part is the coding area where you write your Arduino sketches. Below, the message area displays feedback and progress during the upload process. Finally, the connection area at the bottom shows the status of the serial connection to the Arduino board. How to get started? Get an Arduino starter kit, which includes microcontroller, wire LEDs, sensors, etc. Download Arduino IDE, connect and configure the Arduino. Connect the circuit, write and debug the program. Required items: basic, Arduino, USB A/B, cables, breadboard, hookup wire, LEDs, resistors, sensors, switches. Good to have: capacitors, transistors, DC motor/servo relay. Advanced: soldering iron and solder, heat shrink tubing, battery adapter, bench power supply. Numerous sample sketches are included in the compiler. Located under File, Examples. Once a sketch is written, it is uploaded by clicking on File, Upload, or by pressing Ctrl-U. Arduino Programming Language. Arduino utilizes its own programming language, often referred to as the Arduino language. This language is supported by the Arduino IDE, a software available on major desktop platforms, macOS, Linux, Windows. The Arduino IDE offers a programming editor with integrated library support and facilitates the compilation and loading of Arduino programs onto connected boards. The Arduino programming language is essentially a framework built on C++. It simplifies matters for beginners, although some may not consider it a traditional standalone programming language. In the Arduino context, programs written in this language are called sketches and are typically saved with a .ino file extension. Arduino uses a simplified version of C++ called the Arduino C++ language, which retains essential functionality while omitting many complex instructions. C++ itself is a versatile, cross-platform programming language known for its performance and object-oriented nature. Object-oriented languages like C++ provide a structured approach to programming and enable code reusability, reducing development costs. In Arduino, you structure your code around two main functions: setup and loop. Unlike typical C/C++ programs with a main function, in Arduino the setup function executes once at the program start, while loop runs continuously while the program is active. Once you compile your sketch, the IDE will make sure the end result is a correct C++ program and will basically add the missing glue by preprocessing it. Apart from these two functions, your code can contain regular C++ instructions. Since C++ is a superset of C, any valid C code is also valid in Arduino. One notable difference is that if you use multiple files in your program, they must all reside in the same folder, which could be limiting for very large projects. However, transitioning to a native C++ setup becomes feasible as your program grows. Arduino's programming language also includes built-in libraries that simplify interaction with the Arduino board's features and functions. Arduino programming is structured around three core elements: functions, pre-built actions, values, data like numbers and text, and program structure, how code is organized. Functions handle input, output, math, and communication, while values include variables, constants, and data types. The structure defines the program's flow using setup and loop functions, control statements, and operators. Arduino programs are called sketches. Sketches need two functions: void setup. Setup runs first and once. Void loop. Loop runs over and over until power is lost or a new sketch is loaded. Arduino sketches always loop. Void loop is equivalent to while one. Arduino sketches are centered around the pins on an Arduino board. The pins can be thought of as global variables. Common functions: pin mode designates the specified pin for input or output. Digital write pin value sends a voltage level to the designated pin. Digital read pin reads the current voltage level from the designated pin. Analog versions of above. Analog reads range is 0 to 1023. Serial commands: print on write, writing your first program. Take an Arduino Uno board and connect to breadboard. Add an LED to the breadboard. Connect the LED to the digital pin 13 of the Arduino Uno. Open Arduino IDE. Copy and paste the following code into the code editor. Click on the Upload button. You should now see Hello World on the serial monitor. You should also see the LED blinking on and off. We need to follow some rules in order to code for the code to run correctly. These rules are called syntax. Case sensitivity. Certain words such as void setup in the code must follow the correct case for the code to run. However, the sentence case can be changed in comments and in a text between the quotes. Semicolon. The semicolon is needed at the end of statements. Double quotes. The text is written in double quotes, which is called string, e.g., hello world \n. Adding comments to your code for clarity. Comments are used to explain the code and to make it more readable, which leads in programmers' better understanding of the code. Comments can also be used to prevent the execution of some part of the code. Single-line comments. To write comments in a single line, you must */ at the beginning of the single-line comment. Multi-line comments. To write a multi-line block comment, you must use /* to begin your comment, and you must close the comment with */. Compiling on Arduino IDE. Click on the Upload button. The Arduino IDE compiles and uploads the code to your Arduino board.